Welcome to this video, my friend, on in network theory, fundamental of electrical circuit. In this session, we will learn why network theory is important and what an electrical network is. So, these are the fundamental of every electrical engineer. Why network theory is important? What is an electrical network? Basic electrical quantities, Ohm's law, and KCL and KVL. So, let's begin our session. Why network theory? Foundation of electrical engineering and backbone of electrical engineering. Why I am saying that? Because these systems are used in machine, power systems, power electronics, and control systems in every field and day-to-day life. We are using phone in which semiconductor are used. We are using current in our homes appliances, which are supplied by conductor and aluminum conductor and ACSR, aluminum conductor, steel reinforced conductor and robotics. We are all having network theory in all the applications and required for university examinations and competitive examination like GATE examinations, IIT JEE. In GATE examination, network theory percentage is approximately 15% question are asked from network theory and um, in these network theory are also helpful in control systems, power system analysis, and electrical machine. We are see in upcoming videos. So let's move to the next part. What is an electrical network? So first thing which can come into my mind, and what is electrical network? When I am at in first year of my engineering, I think basic electrical circuit is a transformer. No, no, no. This thing is uppermost value. But if you think the basic electrical network, which are resistor combination of resistor, capacitor, and inductor, and if you take only the resistors and the voltage source, they are also called electrical network. And capacitors and voltage source, inductor and voltage source, capacitor plus inductor plus voltage source, they are called a network, a simple network in an electrical circuit. There are two types of network, active network and passive network. Mm. Active network, which are capable of generating or supplying electrical energy, just like the voltage source and current source. And passive network is that we do not generate electricity but either consume it or store it. Just like resistor, inductor, and capacitor. Capacitor stores energy. Come to the next part of our session, guys. Are you ready for that? Are you excited or not? I am excited. I hope you are also enjoying this video. Basic electrical quantities. Basic electrical quantity, if we give an example, uh, if electricity is like water flowing in a pipe, current is how much water is flowing per second. That's similarly rate of flow of electrical charge through a conductor. So that's why in this formula is called I is equal to Q by T. Current is equal to charge upon time. How much charge, how much electrical charge is flow in a 1 second, flow in a time. So unit of current is ampere and current through only when a closed circuit is present. Faraday law of electromagnetic induction are also said about when a circuit is closed and EMF is induced, current is flow. But when the circuit is not closed, the current is not flow because the circuit is open. So current value is 0 ampere. So take a small and very easy simple example of if 10 coulomb of charge flow in 5 seconds, how much is the current? So current is charge upon time. 10 by 5 equal to 2 ampere is the answer. Come to the next point, guys. Ohm's law. There we can understand through a triangle, Ohm's law triangle. Voltage across a conductor is directly proportional to current. So you can also see that I is equal to V upon R. I is directly proportional to voltage, current is directly proportional to voltage, and current is inversely proportional to resistance. Okay, so let's move to the next topic. Before move to the next topic, we can say that take an example R is equal to 10 ohm, I is equal to 2 ampere. So voltage is equal to 10 into 2 is 20 volt. As simple as that. Okay. So move to the next point, Kirchhoff's law. Kirchhoff's law are analyze complex electrical circuit. If we have a complex circuit, then we cannot use uh, we can use KCL and KVL to reduce the complexity. Okay, we can use just like the KCL and KVL. These laws are based upon the conservation of charge and conservation of energy. It's like the energy is neither created nor be destroyed. So these laws are also based on conservation of energy. So come to the Kirchhoff's law part. Kirchhoff's current law and Kirchhoff's voltage, these are the two types. KCL. In KCL, sum of current entering into a node equal to sum of current leaving into the nodes. It's like these are the nodes. And I3, I2, and I1 is the incoming current, and I4, I5, and I6 is the outgoing current. So uh, I4, I5, and I6 is the outgoing current. So these are all sign are same. And I3, I2, and I1 is the incoming current. They are all the sign are same. So incoming current equal to outgoing current. And incoming current plus outgoing current is equal to 0. These are the mathematical expression of summation of current I is equal to 0. Means summation of all I1 to I6 current is equal to 0, which is said by Kirchhoff's current law. Kirchhoff's body has said that. And come to the next point, Kirchhoff's voltage law. Kirchhoff's voltage law are nothing to solve a complex circuit of voltage, or how much voltage is present in a circuit. So take a clockwise direction of current. So B1. So plus is entered first, so B1 is positive. Plus is entered first, so B2 is positive. Plus is entered first, so B3 is positive. Similarly for B6, B7, and minus is entered first in clockwise direction. So that's why we take BS is a minus sign. So B1 plus B2 plus B3 is all the summation of equal to 0. They all already say that algebraic sum of voltage around a closed loop is 0. So summation of all the voltage around the closed loop is equal to 0. Is nothing but Kirchhoff's voltage law. So come to the most critical part of network theory, and easiest part, or you can also say easiest part, series and parallel circuit. Series means same current and parallel means same voltage. Series, just like we have assumed the R1, R2, and R3 in series. How can this R1, R2, and R3 in series? Because the current flow through it is same. Just like the IR1, I is flow through the R3, and same current is flow through the R2, and same current is flow through the R1. So all the current and all the voltage applying is equal to 0 is applying the KVL. And a resistance in parallel. A resistance means same voltage. If we have B voltage in this, so R3 is the same voltage V, R2 is the same voltage V, and in R1 are the same voltage V. And all the current in the same node. It's like if you apply B voltage in this R1, so same voltage in R2 and same voltage in R3. So these are the same node, and I1 plus I2 plus I3 is equal to I. These are the current in the node. Okay. Okay, come to the next point, current divider rule. Current divider rule are, sorry, first come is a voltage divider rule. The voltage divider rule solves the complexity of the network using voltage divider rule in the network theory. How can it reduce the KVL and KCL in a network? If you apply KVL, then you have to use two equation, and if you apply the voltage divider rule, then you have to use one equation. How? B out is equal to same voltage across the resistance is RB, and the summation of just opposite the resistance RA plus RB into BN. So these are the voltage divider rule. Come to the next part, current divider rule. So you can, if I want to find I1 current, so we can take a input as I and R2. The just opposite of R1 resistance is R2. So R2 in the numerator and R1 plus R2 in the denominator. Similarly for I2, take input as I current and R1. Just opposite of R2 is R1. So R1 in the numerator and R1 plus R2 in the denominator. These are nothing but current divider rule. Come to the practice question part. I hope you are guys enjoying this video. 18 voltage are there, and 6 ampere current are also there. So how can I find the resistance? So I earlier said that if you're using a Ohm's law, V is equal to IR, then we can easily find the value of resistance R. How? V is equal to IR, B is given, current is given. So only we have to find the value of R. So R is equal to 18 by 6 is equal to 3 ohm. Find the voltage across the resistor R in the figure. So in this figure, there are multiple things are there: 5 volt, 17 volt, 7. 1 second, 1 second. So in this figure, you can say that uh, 1 second. Ah, in this figure, 20 volt, 5 volt, and 17 volt, 8 volt, and 10 volt, there are five types of voltage source are there. And a question say that voltage across the resistance R. So we can assume voltage across the resistance R is V1 and apply KVL in circuit. So firstly, we assume current I is flowing through in the clockwise direction. So plus 20 volt, not taking a sign firstly, minus 2 plus, so plus is taking, so plus to minus, minus 8 volt is taking, minus to plus, so plus 10 volt is taking. So similarly for V1, minus V1 because of plus to minus, minus V1 is taking. So we can find the V1 applying KVL in the circuit. V1 is equal to 10 volt. Okay, these are the simple, there is simple and very easy steps to find out the current in the circuit, sorry, voltage in the circuit. Okay, come to the next part. How can I find the current in the 100 ohm resistance and 50 ohm resistance? So in these, if you apply the KCL and KVL, there are two equation and two equation. And if you apply the current divider rule, then the one equation we can find the current. So if we find out the current in the circuit, so firstly we can find the input current. Input current is nothing but voltage divided by resistance. 8 volt divided by 4 ohm. Uh, um, 2 ohm, 2 ampere is the current. So I1 is equal to opposite of resistance is 50 ohm. That's why we take numerator in the 50 ohm and I1. I current is 2 ampere. So 50 into 2 divided by sum of total 100 plus 50, 150 ohm. So 150 ohm. And if we solve them, we get I1 is equal to 0.666 ampere. Similarly, I2 is equal to 1.33 ampere. I hope you are enjoying this video, guys. Uh, have a nice day.